Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. This video is about the course Civil Engineering Laboratory 1 Skab 2012, and we are going to explain on experiment S1, shear force and bending moment. As introduction, the shear force at any point along the beam is the total forces acting perpendicular to the beam longitudinal axis up to the point, while bending moment at any point along the beam is equal to the area under the shear force diagram. The objective of the experiment is to determine the shear force and the bending moment at the particular section with each XX section and compare it with the theoretical calculation. My other group members will explain more about the experiment and how to conduct the experiment.
So next I will explain to you about the procedure about how to conduct the shear force experiment. Let's assume that these are our equipments, where this is our beam with supports on this side point B and this side point C. And we have a cross section here at point B, this white line here. And firstly we have to make sure that the display meter here is set to 0. After that we will apply the various loads on various positions. First, we apply a load of 100 gram of mass, 40 mm away from point A. Let's try to put it. After that, the display meter here will show you the shear force at this section, at XX section, and the value we will record on our laboratory sheet after multiplying it with -1. The experiment is repeated by increasing the load to be 200 gram and 300 gram of mass and moving the loads to be on 140 mm and 380 mm from point B. The same principle is applied to conduct the experiment of shear forces due to UDL and superposition. This is the example of UDL experiment where we use 3 loads of 200 grams, and the first load is located 60 mm from point B, and each load has a distance of 60 mm.
Hello, I am Muhammad Sidanabian. So next, I'm going to show you all about how to conduct the bending moment experiment. So here is experiment of bending moment. I use my own things in my home. So this is the screwing thumb screw. Let's say this one is a screwing thumb screw. This is the bending moment experiment. So this is the digital reading, and let's say if this one is the hanger and this one is the mass. So let's say if there is a moment arm in here, and like what I said, this one is a digital force reading. So the experiment is we put the mass, I assume that this is the mass and this one is the hanger. We put the mass in here in the arm and we set the digital force reading into 0 Newton. And one another thing, before we put the mass, we need to measure first the length between this point and this point, and from this point to this point. After we measure the length, we see from the digital force reading, and then the result we can multiply it and we can find the bending moment. That's all the experiment from the bending moment. I'm sorry for the mistake. Thank you.
Hi, my name is Siti Hairunisa, and I will explain about superposition and the formula that can be used to get sagging equals to hogging moment. What is the principle of superposition? For a linear elastic structure, the load effect caused by 2 or more loadings equals to the sum of load effect caused by each loading separately. As we know that the principle is only limited to the linear material behavior and the structures undergoing small deformation only. This is the simple example for superposition. Thus, the principle is very useful and flexible in solving structure. By using this equation, we can get the sagging moment equals to hogging moment. We can put any value of W and assume D, but D must greater than 0.3 meter. and the result we will get sagging moment equals to holding moment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fatwa Rifai, and now I'm going to explain about the point of contraflexure. Point of contraflexure is when the bending moment value is 0. The aim is to get the bending moment equal to 0 at section x to x. After that, plot the shear force diagram based on both free body diagram and the bending moment diagram. By studying the shear force and bending moment diagram, we find V at B equals to R at B minus the weight, and moment at D equals to moment 1 plus area B minus D equals to 0. After substitute the value of M1 and area B minus D, we get moment at D equals to minus 140 weight plus 300 V at B equals to 0. Then VB equals to 140 weight divided by 300. Equating the equation 1 with equation 2, we get R at B minus weight equals to 140 weight divided by 300. Then RB equals to 140 weight divided by 300. And then the total MC equals to 0 when the weight times 580 minus RB times 440 plus PD equals to 0. So the weight 580 minus 440 weight divided by 300 times 440 plus PD equals to 0. And the result is PD equals to 65.33 weight. In detailed instruction, firstly place the load W at A. Select the location to place the load P. Thus the value of D is known. Determine the value of P, which P equals to 65.33 W divided by D. And then measure the value of bending moment at section x to x. And for the last step, compare the measured mx to x with 0 as the bending moment at section x to x.